Hey folks, in this lesson we're going to be focusing on materials. Now we're going to use the term thermoplastics quite a bit, but it doesn't have to be just plastics. The concept of this lesson is for you to really understand why a material is selected for a certain purpose. And there's two major things to be aware of. One, a material will break because force is applied to it, and as that object is resisting that force, it builds up internal stress. So for example, if I pull on an object like this, I put stress in the middle. Or if I push on an object, that creates stress. Or if I take an object and try to bend it, that creates stress. Which is no problem. A lot of materials are under stress all the time. You know, our chairs, our vehicles, everything. There's always stress internal because external forces are pushing on it. The question is, and the point of this lesson is that stress higher than the stress that the material is capable of handling? So for example, PLA, a common 3D printed material, can handle a certain level of stress. Typically these values are in PSI or they are in megapascals, depending on which system of measurement. So let's just say right here is the stress level. Let's say it's 4,000, 5,000, 6,000 psi. And let's say the object that I'm printing is going to be loaded with force, and that force is going to make a stress that's going to be this high. Let's say it's going to be 10,000 psi. Will the object break? Yes, because the internal stress of 10,000 psi is higher than the, let's just say, 6,000 psi material. And so therefore you have failure. So this lesson is just to make sure you understand why a material breaks versus another material. You know, I might turn around and say, you know, even though I'm using PLA here, the load or the force on the object, that's irrelevant of the material. So for example, if I switch to steel, it is way stronger and therefore no problem. If I switch to aluminum, still stronger, no problem. If I switch to ABS, probably a little bit down below, problem again. Maybe I switch to something like a higher grade nylon. Well, maybe I'm right here now. Or maybe I use some other type of more advanced polymers, because there are materials out there in polymers that are super, super, super strong that, you know, are sometimes as close to aluminum in terms of strength. And that's the kind of thing that we will be watching for. So in this lesson, pay close attention to, first of all, how you go find strength tables associated with materials, and we'll show you some of those. And then what value on that table is most important to you. And typically it's going to be tensile strength, or you know, we may consider ultimate strength, you know, or maybe even yield strength or yield stress. Those again, they're going to be in values of PSI or MPa, depending on which system of units we're talking about. And we're going to compare that to how much stress we're putting on the object. If you understand those two things and how to get the information, you're going to do really well in this lesson. But I want you to walk away with that understanding. I don't want you to just like get it done and move on. I want you to walk away with an understanding of like, okay, I've got this situation where no matter what material I'm using, there is going to be 8,000 psi of stress on the object. Now I need to go select a material that is going to exceed that value so it doesn't fail. Maybe I want it to exceed with a safety factor. All part of your process and understand how to go. And also it helps you not have to spend, you know, money on materials you don't need. If your materials, or if your stress of the object is only going to be like 2,000 or 3,000 psi, you know, you've got a whole host of low-cost materials you can make with this thing. So there's your key factors to think about. Good luck on this lesson. Take your time. Make sure you have a real good understanding before you proceed on, because this is a super, super important part of the whole process and will change the way that you make quality products if you have a good understanding of what material to use. Alright, thanks for watching this. Good luck to you. We'll see you soon.